Science has evolved over the last century to answer some of the most daunting questions about our place in the universe. But even with all the advanced physics and technology we have today, there are still some questions about our universe that keep even the brightest minds up at night. Any unexplainable concept such as this is generally known as a paradox. And in today's video, we'll be taking a quick look at some of the most mind-boggling paradoxes that keep scientists up at night. Arguably the most famous and widely discussed of these is the Fermi paradox. Coined by famous physicist Enrico Fermi back in 1950, the paradox came about when Fermi remarked on the possibility of our galaxy being populated by countless sophisticated life forms and civilizations. But the paradox itself was when Fermi realized that if there were indeed some level of advanced civilization anywhere in our galaxy, then they would undoubtedly be a galactic race. He justified the paradox by stating that any civilization with even the slightest level of rocket or space technology and the slightest inclination to explore could undoubtedly colonize the entire galaxy. These civilizations would simply colonize their solar system and move on to spread across the galaxy, subduing every other star system within a few million years until the entire Milky Way was under one galactic empire. Now, a few million years or even tens of millions may seem like quite a long time, but in the grand scheme of the universe, it's actually not that long. This paradox states that if an alien race did exist, they would have had more than enough time to make their presence known throughout the galaxy. But then the reality is, so far, we haven't seen any clear indication of any such galactic race out there in the universe. This prompts the $1 billion question: where is everybody? In a galaxy believed to be filled with millions of stars and potential life-sustaining planets, why haven't we seen any other intelligent beings yet? This is the basis of the Fermi paradox. Of course, countless physicists, astronomers, and even everyday people have attempted to solve the Fermi paradox in one way or another. Some of the most popular answers include: aliens haven't come here because they can't. Some might believe that we are truly not alone in the universe, but whatever alien race may be out there might just be in the same period of technological or evolutionary development as we are. Despite our best efforts, humans are still yet to step foot on another planet, and it's possible that these alien races might also be as technologically challenged or underdeveloped as we are in terms of space travel. Another answer to the Fermi paradox is: aliens simply chose not to visit us. This might sound like a shade to our species, but we might just not be technologically or evolutionarily interesting enough for any alien race out there to want to visit us. These alien civilizations might be so advanced that we may appear as a primitive race still trying to grasp the basic concepts of rocket engines, while they've been traveling the galaxy for thousands if not millions of years. So there might indeed be intelligent life out there in the universe, but we might just not be interesting or advanced enough to be invited into their galactic club. Another possibility is that aliens may have visited Earth in the past. This is one less debated answer to the Fermi paradox because it puts our possible encounter with an alien race thousands or maybe even millions of years in the past, long before humans ever walked the Earth. However unlikely this might be, scientists have argued that an alien race could very well have visited Earth millions of years ago, but with nothing but unintelligent mammals or even dinosaurs roaming the planet, they moved on and possibly never returned. One new study, however, throws more light on why we might be alone in the universe, and although it wasn't aimed at solving the Fermi paradox, it does fit nicely into the narrative. Earth bloomed too early. This study looks at new data collected by the Hubble and Kepler space telescopes and states that Earth and all life on it might be early bloomers in the cosmic scale of the universe. The study looks at the possibility of evolution and creation of habitable planets like Earth, and not particularly on intelligent life itself. The study states that when our planet and all the other planets in our solar system formed some 4.5 billion years ago, it was at a time when only about 8% of the projected potentially habitable planets that will ever form in the universe existed. In essence, the universe still has about 92% more habitable planets to create before it runs out of the necessary cosmic materials needed to create stars and planets. As such, intelligent life might indeed form elsewhere in the universe, but will come into being billions of years into the future. So we might not have detected any intelligent life in the universe simply because we are quite literally the firstborn, and other intelligent life forms may arise much later in the future. They don't want to be found. Scientists have paused to consider the possibility that intelligent life may exist elsewhere in the galaxy, but they simply don't want to be found. This might be an unspoken rule, where these alien races prefer to remain silent to keep from being found out by unknown cosmic neighbors. This possibility has been postulated by several researchers, including Stephen Hawking, who believed that humanity should not actively blast signals into space, as we have no idea who or what is out there. And if they are out there, they might not be as friendly as we hope. We haven't been listening long enough. It may appear as though the galaxy is radio silent in terms of intelligent life, but it might be that we haven't been listening long enough. Humanity has existed on Earth for merely 200,000 years, and we've only just started listening for radio signals in space since the 1960s. For a universe that is billions of years old, the possibility of humanity picking up radio signals from intelligent life over a 70-year period is pretty slim. What if radio signals from an alien race were broadcasted in our direction 50,000 years ago, or maybe even just 2,000 years ago, but we didn't have the technology to pick up on it? All these possible answers to the Fermi paradox base their theories on if alien civilizations do actually exist somewhere in the galaxy. But if in fact they do exist, what kind of civilization would they be in terms of technological and evolutionary advancement? This takes us to yet another paradoxical theory, the Kardashev scale. This scale was put forth by Russian astronomer Nikolai Kardashev in 1964, where he measured the level of a civilization's advancement into 3 types by the amount of energy they can harness and use. Type 1, or planetary civilization. This civilization consists of a species that have successfully harnessed and utilized all the available energy on its planet and from a neighboring star. These species are able to store all this energy to meet the demands of an ever-growing population. Earth isn't up to a Type 1 civilization, as we have yet to perfect fusion energy, antimatter, and global-scale renewable energy. Humanity would have to increase its current energy output by 100,000 times to fully utilize all the energy on our planet. Reaching a Type 1 civilization would mean we would be able to control and regulate all natural forces on the planet, such as the weather, earthquakes, volcanoes, and much more. Scientists currently rank Earth somewhere around 0.7 on the scale. Type 2, or stellar civilization. This civilization doesn't merely transform starlight, but can completely harness the energy of its host star. They would achieve this by using a theoretical device known as a Dyson sphere. A Dyson sphere is an enormous star-scale device that would engulf an entire star, harnessing most if not all of its energy, transferring it to be utilized by the host planet. This civilization would be able to harness nearby gas giants for their hydrogen on an immense scale, slowly draining them of life to meet the enormous energy demands of their homeworld. This civilization would also be next to impossible to destroy, as they could easily vaporize any killer asteroids or simply move the planet out of range. Type 3, or galactic civilization. This civilization would be a master race, as they would possess every knowledge pertaining to energy throughout the galaxy. If humanity were to ever reach a Type 3 civilization, hundreds of thousands of years of biological and mechanical evolution would result in the humans of this era being incredibly different from the human race of today. This species may be cybernetic in nature, with regular human beings considered as subspecies or inferior beings. This civilization would be able to self-replicate its population using cloning or nanotechnology in the shortest time throughout the galaxy, and could create a huge network of Dyson spheres, tapping into thousands of stars at once and transferring the energy back to their homeworld. All this still doesn't solve the conundrum that is the Fermi paradox, but then again, the Fermi paradox is simply one of thousands of puzzling concepts that science is unable to answer. What other puzzling paradox keeps you up at night? Let us know in the comments, and we'll see you in the next video.